Hi everyone, today we shall discuss regarding LM317 and LM337 IC regulators. So here the LM317 and LM337 IC regulators are three terminal devices that are extremely easy to use. And here 317 is a positive voltage regulator and 337 is a negative voltage regulator. 317 is a positive voltage regulator and 337 is a negative voltage regulator. In each case, input and output terminals are provided for supply and regulated output voltage, and an adjustment terminal, that is ADJ, is included for output voltage selection. In each case, the input and output terminals are provided for supply and also for the regulated output voltage, and also for ADJ, it is included for output voltage section. So here the output voltage range is 1.2 voltage to 37 voltage, and the maximum load current range is 300 milliamps to 2 amps. And depending on the device package type. And here line and load regulations. Line and load regulations as specified, that is 0.01% and 0.3% respectively. Line is 0.01%, load regulation is 0.3%, and V0 equals to V reference into R1 plus R2 divided by R1. To determine the R1 and R2, for a desired output voltage, I1 should be selected. It should be a much larger than the current that flows in the ADG terminal of the device. So how we need to select the current I1 means it should be more, okay, it should be larger than which is the current flowing in the ADJ terminal. For example, the current 5 amps is flowing in the ADJ terminal means it should be I1 should be more than 5, like that. Okay, so I1 is selected to be much larger than the current that flows in the ADJ terminal of the device. C-in is necessary only. C-in when it is necessary only when the regulator is not located close to the power supply filter circuit. So C-in is necessary only when the regulator is not located close to the power supply filter circuit. The various protections such as thermal overload, short circuit current limit are internally provided in the LM337 voltage regulator. And LM337 voltage regulator is a negative voltage regulator. We already said that LM317 is a positive and LM337 is a negative voltage regulator, which can be used as an adjustable voltage regulator. Adjustable voltage regulator. LM337 can be used as an adjustable voltage regulator. Here, so the various protections such as a thermal overload, short circuit current limit are internally provided. And here LM337 is very easy to use and require only 2 external resistors to design. And here C-in eliminates the oscillatory tendencies that can occur with the long connecting leads between the filter and regulators. And here capacitor C0, which will improve the stability and improve the transient response of the regulator. And C adjust, that is C adjust, improves the ripple rejection ratio. This you remember. C-in which will eliminate the oscillatory tendencies that can occur with the long connecting leads between the filter and the regulator, and C naught, which will improve the stability and also the transient response. And here C adjustment, it will improve the ripple rejection ratio. So you can observe here C in, C adjust, and C naught while we have connected. Okay. This is a LM317 positive voltage regulator. And LM337, that is negative voltage regulator. So output voltage range is minus 1.2 to 47 voltage, and the output current capacity is 1.5 amps, and the here load regulation is 0.3%, line regulation is 0.01%, we already discussed, and high ripple rejection of about 77 decibels. And here internal thermal and overload protection is provided. Internal short circuit current is also provided. Short circuit current limiting is provided. And so you can see this voltage regulators, how it is adjoint, ADJ, that is adjustable. Okay. Adjustment terminal, it is ADJ is the adjustment terminal, V out, V in. So it is a positive LM317, LM337 negative output, V in, V out, and adjustment terminal. This is, you can see how it is. So when you see this, V input is this pin and V output is in the middle. Okay. Here in the middle, input is there, and the side one, it is third pin is V out. Okay. If you see the difference between the 317 and 337. So you can write the formulas also here for this. You can write the formula, that is V naught equals to, here I have not written, you can consider that V naught equals to, that is minus 1.25 into 1 plus R2 divided by R1 plus I adjust terminal, that is R2 into R2. Okay. So here, what the problem, in the problem, they have asked to find the range in which output voltage can be varied with the help of the LM317 regulator using R1 and R2 as these values. So I adjust, that is ADJ equals to 100 microamps and R2 equals to 0. We don't know initially. Okay. V naught equals to 1.25. Oh, this is a formula. And when R2 is maximum, okay, when R2 equals to 10 kilo ohm, what is the V naught? 1.25 into 1 plus R2 value you substitute, R1 value you substitute, plus 100 into 10 to the power of minus 6 into and 10 into 10 to the power of 3. So that is what equals to what you'll get, 17.49 voltage. Okay. Output voltage can be varied in the range of, so initially the voltage should be always V naught voltage should be, usually output voltage range is minus 1.2 to minus 47, right? So now output voltage range has been changed to 17.49. So 1.25 voltage to 17.49, it has been changed. Now calculate the resistance of R1 and R2 for the LM317 voltage regulator to produce an output voltage of 9 voltage. Draw the circuit diagram. So R1 equals to V reference divided by IR1. IR1, that is V reference is 1.25. IR1 is here 5 into 10 to the power of minus 3 we have taken here. because the standard value we have taken the current value 250 ohm you will get, and you use a standard that is 270 standard. IR1 equals to 1.25 divided by that is 270. If you do IR1 you'll get 4.63 milliamps. Okay, and R2 equals to V0 minus VR1 divided by IR1. So V0 value is how much they have given in the question, 9 voltage. Okay, and minus VR1 is VR1 initially the standard value voltage 1.25. IR1 how much we got, 4.63 milliamps. That you substitute and get the value of R2, it is 1.67 kilo ohm. Okay, that is a use 1.5 kilo ohm. That is the standard, and 220 ohm in a series. So this is the circuit for that R1 and R2. With a schematic diagram, explain LM317 integrated circuit voltage regulator. Calculate the resistance of R1 and R2.